some point. So I don't really visit InfoQ too much, but if I want to cross out somebody that's going to happen, I'll send the link along to them.
Hold on there, buddy.
Sure.
How many live viewers do you guys usually get? Any ideas?
We currently have 5.
5, wow.
We'll see how that stacks up. All right, so you're gonna have to talk up because you're not mic'd. So.
Not mic'd? Okay. Can everybody hear me all right? All right, so yeah, like I said, this is a talk that I gave at CodeMash, and so this talk, I proposed this talk kind of as a way to kind of share what we've learned from being, I guess, fairly early on the curve as far as doing Backbone apps. I think we started doing our first Backbone app a couple of years ago-ish, when I proposed the talk. So yeah, this is kind of sharing what we've learned and hopefully maybe some pitfalls and things you can steer clear of if you're newer to Backbone, and you know, some things that have been helpful on projects that we've done. Kind of got a feel for who's here, but how many people like haven't done any Backbone yet or are not too familiar with the pieces? So we'll spend like just a few slides going through what Backbone is and what the pieces of it look like. But most of the talk is about things that Backbone doesn't necessarily include, but are concerns you need to think about as you build a real-world Backbone app. So that's more the focus of the talk. But I'll start just sort of by introducing you to Backbone. If you haven't heard anything about Backbone, basically what it is it's a client-side MVC framework. So if you've done web development these days, most people are using a server-side MVC framework. MVC is Model View Controller, and it's a way to organize your web application and code better. And so initially, these frameworks were on the server side, and that worked great when you were doing everything with, I submit a web page and do something, and then the whole page refreshes, and you know, everything I do causes a new page refresh. When we were building web apps that way, server-side MVC frameworks were great, and they were all we needed. But as web apps have gotten richer and richer on the client side, it really became time to think about how do we organize our client-side JavaScript code better. And so that led to client-side MVC frameworks. And Backbone is one, and it's been a great tool for us as we've developed these apps. And the really nice thing about Backbone is it's really lightweight. It doesn't try to do a whole bunch of things, which is awesome in some ways, and also means you have to do some things by yourself and deal with them yourself outside of Backbone. But it's been really easy to get going with on new apps, and the barrier to getting started with it is pretty low. It makes it a great fit for different kinds of apps. But let's look at some code. The pieces of Backbone, like I said, are model view. We'll talk about routers as well. They're kind of what Backbone calls controllers. But this is an example of a model in Backbone. And a model in Backbone kind of serves the same niche as a model on the server side in that it represents your domain. So if you were building a cookbook application, for example, you might have a model called recipe, which represented your recipe. In the case of Backbone, models, if you're used to server-side MVC frameworks, models usually do persist to a database or something like that. In the case of Backbone, models know how to talk to your backend if your backend is built to handle RESTful requests containing JSON. And so, in the case of Backbone, you need to tell it where the root of your URL is, or if your collection, just what the collection to get to the what the URL to get to that collection, excuse me, is. And then from there, if you follow the REST conventions, like, for example, if I do a post to /recipes with a body containing JSON, it will know that I'm trying to create a new recipe. And if you're getting, if you make a GET request to /recipes/1, your server knows to return the JSON representing the recipe by D1 and so forth. And if you follow those conventions with your backend, Backbone just knows how to talk to your backend already. And since I've mainly done a lot of Rails development over the years as my backend, and it follows those conventions, and Backbone, in fact, was extracted originally from a Rails app. It just fits together seamlessly with my backend, and that's been a really big, it's made it really easy to use and get going with. So back to what we're looking at here, we have a model, a recipe model, and then the other piece that we're looking at is a collection, which represents multiple recipes. And with the collection, you have to tell it what model, what kind of thing it can hold. So that's just a very simple example of a recipe, or of a model and a collection. So one of the other pieces of Backbone are views, and views represent DOM elements on your page. So this would be an example of a recipe edit view, and it would be in charge of a form to edit a recipe, for example. And I should have probably pointed this earlier, and actually I probably should have asked earlier, but how many people are familiar with CoffeeScript at all? Because if this code is looking weird to you, it may be because you haven't seen CoffeeScript before. CoffeeScript, briefly, is really just a better syntax for JavaScript. Well, in my opinion, better. It's certainly less verbose. I say objectively. You're going to write less code in CoffeeScript almost all the time than you would in JavaScript. So classes aren't a out-of-the-box JavaScript construct. They're something that CoffeeScript gives us, but they compile into the same kind of object functions in JavaScript that if you were rolling class type things in JavaScript that you end up writing yourself. But in this case, with Backbone and CoffeeScript together, we end up writing a lot of classes that extend from Backbone core classes, which are really just JavaScript functions at the end of the day. And in this case, our recipe view extends from backbone.view. We have a property of our class, which actually is just under the covers going on the JavaScript prototype of this function. And the events object property here is how we tell Backbone how to map DOM events to methods of our view class. So what this is saying is, if we have a click event on an input whose type is submit, we want to invoke the save function of this view. Down there towards the bottom, it gets passed in an event. Because we don't want the default behavior of form submission to go through, we tell it to prevent the default on that event. And then we are responsible for updating the model ourselves. That's something to point out about Backbone. Other JavaScript frameworks that are more all-encompassing kind of try to take care of more of that for you. But what we're doing here is we're basically setting properties of our model. We're setting the title and description of our model to the form element values that represent the title and the description there. And then we're telling the model to save. With Backbone and, well, JavaScript MVC frameworks in general, when you do things like calling save, that's going to be asynchronous. So something to point out there. we're going to have to listen to what happens somewhere else in the code. So that's a simple view example. I guess it's worth covering the render method there as well. We'll look at client-side templates in just a little bit, but in our render method, we're actually just calling a jQuery call on our DOM element to populate that DOM element with HTML from our template. So I realize I'm going through this really fast, and this probably isn't enough to, if you've not seen Backbone at all, you're not probably going to go away and be able to write Backbone code, but hopefully this gives you a feel for what's going on. The rest of the stuff I go through will make sense. So let's look briefly at routers, which is another major piece of Backbone. Routers used to be called controllers in Backbone, and they decided that wasn't really a great name because the primary responsibility of routers is to route requests kind of at the... So if you have links within a single page application, routers are the construct to be able to handle those intra-page links. And they do that by monitoring the hash change event. So if you have a anchor link, so a link that goes to, in this case, pound recipes/1, for example, it will intercept that event, or it will respond to that link and invoke the show recipe method. So that routes property there is the key to how routers route. And you can have parameters in your route here, so that colon syntax means that's a route parameter. Then that the link will actually go to recipe, pound recipe/1, and then it will invoke show recipe passing in 1. So that's really briefly how routers work. I tend to like routers to kind of be the, to coordinate between the multiple views that I might have within the page. So I, in this case, have my recipe router be in charge of constructing my recipe view and recipe edit view and recipe list view and so on. I also like to put kind of the page setup logic if I have any in my routers. So in this case, I have the recipes being fetched as the application starts up. So yeah, those are kind of the key pieces of Backbone.
Yeah. On the previous slide, I was just going to ask about what you just said. Can you talk more about doing all your app setup in the router as opposed to doing it in some like main container or main view?
Yes.
Because usually
so here's kind of like so here's kind of the actual on-load event for the page where I like basically kick off the application. Mm-hmm. And this is kind of similar to what I usually do in Backbone application. If I had like a web app, if I had like a web app where I had kind of multiple sub-applications, like multiple Backbone, pages where I have a Backbone application within that page and I had multiples of those, I might have some intelligence to be able to figure out, okay, which router do I actually need to kick off here? But in general, I have usually one router per page, and I have my kind of DOM ready event just kind of initialize, construct that router, and then here is the call to tell Backbone that I want you to start listening to that hash change event and have the router start routing. So it keeps my on-ready event really, really small and moves more of that setup code into the router's constructor. And I found that to work pretty well in my Backbone apps. Is that?
Well, I was asking more, like what I usually do is put that setup code inside like a main view or a container view as opposed to putting it in the routing structure. I don't know, I just didn't, so I was just asking if there's some reason you put it in the router instead of like a...
I kind of have liked having, if I have multiple views that need to coordinate something, I like having the router to own that kind of a thing rather than the views to, talk directly to other views and call methods on other views. I've just found that to work out pretty well from a design standpoint. I think
Okay,
it was
that
Doug
helps.
who kind of pushed me in that direction first, and he's at lunch, I'd have him.
Okay, yeah, I can see how this might be a little easier than having like a main view, create your recipe view, and have that create your its edit view. And so
I certainly started with like a view that, you know, one view that kind of was the application view and kicked off
Yeah.
other things. And that's okay, but I kind of felt like this was better designed, and it's fairly subjective. So let's talk about code organization. So Backbone out of the box is really a, you know, there's some debate, you know, about whether it's a framework or a library, but at the end of the day, it's a JavaScript file that's a few hundred lines. It's not big at all. And it doesn't try to deal with things like organizing your code for you. And so what I mean by code organization is as you start making larger client-side applications, just cramming a bunch of code into, you know, one or multiple JavaScript files that are kind of arbitrarily named like we used to do really becomes unwieldy and really awful. And what I found to be a really good practice is basically to mimic what I would do in my server-side code, which is, you know, if I'm writing object-oriented JavaScript, having one file per class and organizing them into directory structures that make sense, like a models folder and a views folder and etc. You know, just kind of common sense-ish kind of approach. But if you do that, you need something to bring those files back together in a sense and serve them down to the client in the right order. And that's what I mean by managing dependencies. And well, that's really packaging, and then managing the dependencies is about internal dependencies, which is, okay, if I have, you know, one view that's a subclass of another view, for example, I need the base class to be served first, or things will break. Those would be an example of internal dependencies. But I also have external dependencies, like, okay, I'm building my application, and I depend on Backbone, and I depend on other JavaScript libraries, and having a tool to manage those dependencies and managing that packaging process really can make development a lot less tedious. And I'll talk about a couple of tools that we've used on projects. The first one, and kind of generally still my go-to, is the asset pipeline. The asset pipeline is a feature that's built into Rails. It's built into Rails 3.1 and later. And it kind of manages a lot of these things that you need as you build apps like this. It is aware of the different things that you need in development versus production. So for example, in development, it's really nice to have each of my classes served up as separate scripts so that I don't have like one big file in my debugger that I have to scroll through to find what I'm looking for. But in production, I probably want it combined into one big file and minimized so that I can optimize for performance. And the asset pipeline will just do that relatively automatically. It's just a matter of configuring it to do what you want it to do as far as minimization of production and so forth. It also, I still feel like, has the best, or at least a really good solution to managing external dependencies. And there's a little bit of a trade-off there, and I'll talk about that on the next slide. But it does let me say, okay, I want to depend on Backbone, and Backbone can depend on the other libraries it requires, and it'll manage that whole transitive dependencies thing for me. And it'll also, it uses Ruby gems as the specific mechanism to do it, but it will know where to go out and fetch those things, and I run a command called bundle install, and it'll fetch all my dependencies and grab them and put them where they need to go. So I can, I don't have to go download a bunch of JavaScripts all over the internet. You know, it does that for me. It is baked into Rails, which is awesome if you're using Rails, and if you're not using Rails, well, I'm sorry. The other thing that it does is it manages client-side templates for me. And we saw an example of that when we were looking into the view, although I didn't talk about it so much. But client-side templates, we'll talk about the different options there in a couple slides, but the asset pipeline has some functionality that will compile my client-side templates and make them available to the rest of my code really conveniently. And that's, the JST is like the top level constant that it puts those things on. So there's like a window.jst that it makes available to me, and that then holds all my compiled client-side templates. We'll see an example of that in a little bit. It also manages CSS and images as well. So that's nice too. So the things that aren't as great about Asset Pipeline, and that first one's obviously, that's either a pro or a con depending on your point of view, but it is Ruby, and just in general, like philosophically, it's still, I gotta admit, it still feels weird that I'm using this Ruby tool to manage all my JavaScript. It just feels strange. And then if I'm not in a Ruby environment, it can be, you know, well, now I'm having to do this other thing if I want to be able to use the asset pipeline. So it also doesn't totally try to solve namespace issues as far as like having, for example, putting Backbone, if I want to bring in Backbone, it's still going to be window.backbone, and if somebody else tries to define a window.backbone somewhere else, it's still going to step on that code. And it doesn't do anything to address that issue. You just have to kind of be aware and be careful and not be overly intrusive on the global namespace. And the next, the other thing that we've used to solve these kinds of problems actually does deal with that. We'll talk about that. So the other thing that, well, I'm sorry, I'm getting ahead of myself. So this is some code that actually shows what the asset pipeline looks like. This is CoffeeScript again. And how the asset pipeline works is it uses what they call directives, which are just special syntax in your comments to tell it what to do. And so at the top I'm saying I require jQuery and underscore and backbone and Hamel coffee. Those actually happen to be external libraries, but because I have those listed as gems that I depend on, it will know where those specific JavaScript files are and bring them in. So that's pretty cool. And then below that is where I'm kind of telling it where the directory structure on my app is. That require self is a special require that says, whatever's in the rest of this file down here, put it here. And the reason that I'm doing that is, I mentioned earlier about namespaces, and this is in general the kind of technique I use to minimize my impact on the global namespace. So I usually set up one top-level object that I hang on window. So in this case, I'm just calling it app. And then all my other things are within that. So I only have like one thing where, you know, if I call my whole app cookbook, as long as nobody else steps on cookbook, I'm okay.
Wouldn't you need to say window.app there?
I don't think so. I think by default it will, that will be the scope.
I thought it would do a var app. Maybe I'm not.
I will, in a little bit, we'll actually look and see what I have in my actual code base, rather than wherever I copied this from. Excuse me. So those required directories are just bringing in the models, collections, services, templates, and views.
When you require, you say require jQuery, does it download jQuery, or do you have to do that?
So I have a gem that is actually packaging jQuery. And so that gem process, when I do module install, that will actually fetch that gem that contains that JavaScript.
Okay.
And this will say, okay, somewhere there's a gem that defines a jQuery.js, and go find it.
You could also bring your own files in if you wanted to.
Yeah,
Like if you depended on some crazy library that there wasn't a gem for, you can.
Yes,
totally bring
that's
that
true. It will. So when I say require like that, there's a set of places that it looks.
Vendor assets.
The first thing that it does is look within your application. So if it's somewhere in, I think, app assets or vendor assets, which is like just sort of like for stuff that you want to grab from somewhere that isn't packaged into a gem. And then if it doesn't find it within your application, it will look through all your gems that can also define, you know, their own app assets directory and so forth. So that's the mechanics. The other thing that we've used to manage dependencies is require.js, and Kevin's really done more of this than I have, so I'll go through this, but if you have like specific things where I got something wrong, Kevin, jump in. So the nice things about require.js, and that first one is sort of a nice thing or not a nice thing, depending on specifics. But it is, or can be, asynchronous in terms of how it loads things. So that can be really nice sometimes, in that if I want to load something asynchronously, I can have my app be more responsive initially. It is like it is an all JavaScript solution, rather than requiring something external like Ruby to do things. It lets you manage namespaces very explicitly, so that you don't have to define things globally. Some things that are not as awesome about it, that asynchronous business, so that can be a good thing or a bad thing, and where it can be a bad thing is if you load things asynchronously all the time, you're actually not taking advantage of browser optimizations. Browsers have gotten really, really intelligent at how they load things from just straight up script tags, and if you're doing that yourself in JavaScript, it's not going to be able to optimize for you. It doesn't address CSS and things so much, and out of the box require.js doesn't really do anything for you as far as external library dependencies. There are other things that kind of layer on top of it, like jam.js, that we've used that do that, but it doesn't seem like as a whole the JavaScript client-side community has really rallied around a single solution for managing libraries like Ruby has with Ruby gems, or Java has, I guess, with Maven. It doesn't seem like there's a single thing that's emerged yet. I'm still kind of hoping that something will. There's certainly lots and lots of things.
So ES6 is just standardized the JavaScript module format, and I don't know if that's been like officially accepted, but I know that recently they've like said here is the module syntax.
Does that say anything about? So that would be like more packaging, but does that say anything about like, okay, go find it here?
Yeah. So it does.
It does that too.
It'll do all sorts of stuff, but the downside obviously is that it's ES6, so it's only going to be supported in the newest of new browsers, and only those browsers that choose to support it, which means like to reliably use their new module system, you're going to have to wait 10 years for IE to catch up.
What about shims?
There might be some sort of shims coming out, but the problem is that you're basically, the way that they're doing it is kind of like, you need to like redo the way that JavaScript handles like loading things, because like they're actually making like synchronous calls out to like get stuff before it loads other things, and it's really I don't know how well it's gonna meld with other JavaScript frameworks. I know that they tried to follow like the Node.js module system, but it's not exactly like it. It's like this weird in between. So I don't know. We'll see how it works. Hopefully,
we need a future talk on ES6.
Yeah.
Modules.
Bring.
So, are you?
I volunteered.
Yeah. Kevin knows a lot about it.
Here, Kevin knows.
Are you saying if stuff like that is incompatible with require because requires AMD?
Well, yeah, require is, requires like an external tool, just like jQuery is.
Right.
Yeah.
But this module system is going to be like baked into JavaScript. So you can say like var jQuery equals fetch jQuery, and it will like go out and find jQuery and like pull it in and do all that stuff, which would be really cool. But in order for that to happen, it's got to do a bunch of stuff behind the scenes, and who knows when all the browsers will support it.
So I was going to look at some
Oh god, this is awful.
require.js code, and I'm actually stealing Kevin's code there, so he's making horrible faces at me. So this is where we actually use require.js and kind of initialize and set up the application. We bring in require.js, and then we tell it what we want to require. In this case, we have a single init.js module, which is responsible for requiring everything that it needs. And then we're calling a function that it gives us to kick off the application, essentially. So if we go look at that init module, here's an example of how we define a module using require.js. We have a define function that we call, and we pass define a list of our dependencies for this particular module. In this case, we're saying we require Backbone and jQuery, and then pieces within our application itself, app base and app router. And the nice thing is it passes those into our function that we define, and this is how we avoid having to have things be available as top-level globals on Windows. So we call it Backbone, and we call it capital B Backbone in here because it just makes sense to do that, but we wouldn't have to. And if somebody else defined a window.backbone or something, it's not going to step on this definition of it because it's local to this function. So that's kind of cool.
The thing I've found with require.js is it's really cool when you get it to work, and it's getting it to work and getting everything to play nice, because you can actually run into like race conditions where like one module depends on another module, and that module might like
circular dependencies.
Yeah, you can have circular dependencies really get screwy. So when you define things well and you like set up a nice tree that's like all down, top down, it can be really awesome and it works fairly well. But I found that I spend a lot of time debugging it, and that kind of sucks.
So I mentioned also that we were using this Jam.js thing, or Kevin was using this Jam.js thing to manage dependencies on this project. And this is what the setup for Jam looks like. And these things are all external dependencies that I guess is it just on the Jam.js site, or how is it actually registered?
Yeah, so if you go to jamjs.org, they've got a list of all the... Basically, they've created require.js packages for a bunch of libraries, like Backbone _ jQuery. And then, so Jam helps you manage that external dependency chain.
So you run a command and it actually downloads these things and puts them somewhere that your application can find them, which is cool. But it seemed like Jam.js, I hadn't seen any like new additions for a while. It seemed like
I haven't really checked.
It seemed
the
really
site
cool,
in
and
years.
then nobody like jumped on, and it seems like it's
Yeah,
not really.
it takes a lot of the headache out of require.js, but it's I don't
not
know.
much momentum.
Yeah.
So that's pretty much. Oh yeah. So I think most of all I wanted to say about that. So the next thing. So the other really important thing in my experience that makes client-side code a lot stronger and better designed is test-driven development. So I thought I'd talk about some of the options or some of the things that we've used to test drive our Backbone apps. And for a long time, I was doing a lot of Jasmine and Jasmine jQuery. Jasmine is a testing framework that, well, both of the testing frameworks I'm going to look at look very similar to RSpec. So if you've done much Ruby, or I'm trying to think if there are other things that look like RSpec in other languages that people might have seen. But they're kind of more behavior-driven development, and we'll see some code, and then maybe it'll make more sense. But if you've seen RSpec, it's going to look very familiar. If not, I'll kind of talk through what the pieces of it do. But more recently, we've been using Konacha and Mocha and Chai, and they're kind of three different libraries that come together that they look very similar to Jasmine, but they kind of have some improvements that make things even a little nicer. But with the main problem that I had to solve when I started test driving my Backbone, and this is true whether I'm using Backbone or even just plain old jQuery, is how do I write unit tests that don't interfere with one another and manipulate the DOM? So if you've done test-driven development generally, you want your test cases to be isolated in that you never want your tests to do something and then depend on that happening, depend on the results of that in another test. It's just kind of like bad news. It becomes really unwieldy to manage and just all kinds of terrible. But if I'm test driving code that works with the DOM, and I'm running that test on the browser, essentially the DOM is like one big global thing. And if I run a test that turns an element of the page blue, and then the next test runs, it's already blue. So how do I solve that problem and prevent these tests from stepping on each other? And Jasmine jQuery was a library that we've used quite successfully in a lot of projects. And its approach is it gives you a specific element, a specific sandbox element, that it creates and destroys before and after. I may have gotten my word wrong there. It executes each test case. So it creates it before the test case runs and gets rid of it at the end of the test case. And so what I'm free to do is any of my view elements I create within that sandbox, and then it's safe to do whatever I want to there because that element's going to be cleaned up for me. And Konacha has a different approach to solve the same problem, and we'll see what that is. It basically runs each test in a iframe, so that's completely isolated and kind of nice. So let's see a Konacha example, and I think this is a test of our main Gaslight website. Is that right, Kevin? I'm stealing a lot of code from Kevin. You recognize this at all? This
yes,
is you, right?
Yes, that is our website.
That is our, well, let's go see our website, because our website is awesome. So let's go look at our website. It's super nifty. And so you see these little dudes that go around and like give you something fun to look at. So that's implemented with, I'm drawing a blank here. It's SVG, but what's the, Raphael?
Raphael, yeah.
Okay.
And each one of those lines is actually a Backbone view. And the Backbone view manages Raphael. Because doing straight up Raphael is kind of crazy.
So this is a test case for one of those guys.
Mm-hmm.
And we're setting up Raphael, of course. And we're having a guide model that contains some data about, this is a path, right?
Yeah, so each, how did I do this? So a guide is a line, and that can have many points, as you see there. And then each guide also has a shape, the square that follows around on it. I can't even remember how I did this exactly.
So I guess what really is important here is if you haven't seen tests that look like this. In general, the kind of pieces are, I'm describing something, I'm describing the behavior of something. So I have an outer call called describe that I pass in, that string is just a label for what I'm interested in testing. And then the second argument to describe is a function. And within that function, I can have nested describes if I want to. I can also have before each, which is a specific function that just runs before each test executes. So in this case, I have one outer before each, which is setting up the things that I need to have set up in my test. And then I have inner describes that are more specific. So in this case, I'm describing a constructor, and here's actually a spec. Specs are calls to an it function. An it function has another string label and a function that I'm passing in. And this is actually an example of an assertion or expectation. So I'm saying, I'm describing my constructor, and I'm saying that once I've constructed it, the shape view should have a paper. So I'm saying shapeview.paper should, and this is a special function that I think Chai gives us. So Kanacha, Mocha, and Chai are three different libraries that kind of plug together fairly seamlessly. And it should exist. So this is basically saying it should be defined. So I have some other examples down here of assertions using Mocha. I'm saying the shape view shape should have an attribute called fill that should equal whatever the guide's fill attribute is. So let's see what that looks like in the runner. So this is running all of these tests within the browser pretty fast, as you can see. And one of the cool things about Kanacha is because it runs each test in the iframe, I can actually, if that test actually does something visually, I can see it. In this case, I think this is just showing me what the Larry last test did.
Yeah, and if you drill down on any one of those, you'll see the actual thing going in.
I can click on an individual test to run just that test. I don't know if any of the other ones do something that we can see. Probably so.
Maybe not.
Maybe not.
I don't know.
So if they did, I would see what they did over here. And that can be kind of handy.
And that's just part of the library that we're using to test, right?
This is Kanacha. This is actually the test runner. So I mentioned there's like three different libraries that work together. I think Kanacha is really just the test runner. Mocha is kind of the testing framework that gives us the describe and the before each and the it. And then Mocha is the assertions themselves, and that's what gives us the should.
Chai is.
I'm sorry, that's the But from a user point of view, if I just install the Kanacha, that's just a gem. I just install the Kanacha gem in my Rails project, I get all those other things, and I don't have to worry about what I click on or which piece is which. This works. Anything else I can say about testing? Questions?
I've kind of flipped my opinion on the should method.
You don't like the should anymore?
It was cool for a while.
What swayed you, or what did you run into?
So if you call should on undefined, it blows up. So if shapeview.paper is undefined and I call should on it, it's just gonna like die. Or it's gonna say like undefined doesn't have a method should.
So, but isn't that like just a property of JavaScript having lots of bottom values that suck?
Yeah. So not
runner, what does in the runner, does it just say, hey, you tried to call blah 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 on undefined or something?
Yeah, but it can get a little. So the way that the should method works, this is like a chai thing. Basically, before any of your tests run, it modifies object.prototype to put a should method on there, So basically, any object that you create in JavaScript is now going to have a dot should, and that should method has a bunch of methods on it, like it exists, and you can pass in some things that you want to. But the problem is that like 99.9% of JavaScript things inherit from object.prototype, but like a few things don't, like undefined, nil, weird cases like nan doesn't, some like weird string things don't. And so if you call should on those, they just blow up and then things get weird. I ran into a situation where like I wanted to test that something was undefined. Like I actually wanted it to be undefined, and I couldn't say like, hey, this thing dot should be undefined, because it would just say like, well, it's undefined, I don't have a should method on it, I'll just blow up.
Yeah.
So there is, so I should say, Chai also has a more Jasmine-like syntax where you actually say expect, pass it something, and then call should on what that thing returns. And I found that to be much more robust.
So on the undefined thing, could you have used CoffeeScript's existential operator and then wrap that in should?
I could, yeah. And you could say expect something question mark to be false or whatever CoffeeScript's existential operator does.
Yeah.
Mm-hmm. So Chai is awesome, but I would stay away from the should method and just use the expect syntax. Sorry, way off the reservation.
I was just going to see if we had an example handy of what the
Yep. So there is.
expect and should.
There are two things that it does.
So this looks a lot more like Jasmine, for example, where I expect something to not equal.
Mm-hmm. And that will work if foo is undefined, and you call that, it'll be fine. It'll just say, oh, undefined.
Undefined doesn't equal whatever, blah, blah, blah.
Yeah. But if you call should, if you scroll further down the page, it talks about the should things, and it just gets weird.
We're getting way off topic.
Way off topic.
So, templating frameworks. So Backbone doesn't mandate that you choose a particular client-side templating framework. So that's kind of interesting.
Thank the Lord.
So there are lots to choose from. Echo is embedded CoffeeScript. That's one that we've used a lot, and that works pretty well. If you're a HAML person, if you're a HAML fan, there's a CoffeeScript implementation of HAML that you can use called HAML Coffee. I've used that and liked that pretty well. EJS is just embedded JavaScript, so it's the same as Echo except with just JavaScript and not CoffeeScript. And then Jade, I haven't used Jade, but Jade is similar to HAML, but
it's less noisy than HAML, if you can imagine that.
But it's just JavaScript in terms of any code that you have inside of it.
Mm-hmm.
So.
And it's compiled by JavaScript, so it's a good fit if you're doing Node or something.
As is HAML and HAML Coffee, and Echo and so forth.
Oh, yeah.
Handlebars is kind of a different approach altogether. It's logic-less templating, and that I can't actually write code inside of it. Just kind of interesting. We used it early on and didn't really dig it so much, but
you can call code though, right?
You could
write handlebar helpers and do things.
Mm-hmm.
So this is an example of what an Echo template looks like. And if you've done any server-side templating language, they almost all use the same syntaxes, like angle bracket % to do code, angle bracket % equals to actually grab the output of what's inside there. So here I'm just looping over all the recipes in my collection and generating a list item for each one, and then within that list item I have a href that goes to pound recipe / and then whatever the ID of that recipe is, and I'm displaying the title by calling recipe.getTitle. So the other piece to talk about is how do I actually talk to my templating framework? And I talked earlier about the JST that the asset pipeline gives me, and this is an example of using it. So how the JST works in the asset pipeline is based on putting a file with the right set of extensions in the right directory. It will know that this is a template that it needs to compile. So in this case, underneath the root directory of the asset pipeline, which the one I always use is app assets JavaScript, excuse me. Within that, there's a Backbone directory with a templates directory and a file called recipe list view. And in this case, it's going to be called recipe list view.jst.echo. And what that means is it looks at the file extensions in reverse order and figures out, based on the file extension, what do I need to do to that file. So we'll see that echo extension, because it's last, it will process it first and go, okay, this is an echo file. I know how to handle an echo file. I'll run it through the echo compiler. So the result of that is a function. And then it processes the JST extension next, which tells it this is a JavaScript template, and that's what makes it available on that JST top-level global object. So the net result of everything is the function that results from compiling my template is a property of this top-level JST object. So I'm basically setting a property equal to the compiled template function. And then when I actually render my view is where I use that template. So this long line is basically saying, call the template function by pass it this as the argument, and the result of what that template function does is what I use to populate the HTML. So I pass the argument of this into that template function, and the reason that I do that is that's the scope for the function. So if I go back and look at that template one more time, I'm referring to this .collection over here, but of course the question is, what is this at that time? This is this, which is the view itself, is the actual answer to the question. So the value of this is always kind of a confusing topic in JavaScript, at least to my mind historically. But I found it to be a good practice when I'm using Echo to always have the view be the scope for the template. The reason that I like that is if I define other functions of in my view, they essentially can just kind of turn into helper functions that I can invoke in my template. And that's kind of cool and kind of handy. I like it. So I'm probably running out of time to get through everything. I'm happy to keep talking if people want to stick around, but let's kind of look at the other pieces that I had and talk about which ones people really want to see. There's a section on looking at server-side errors. There's a section on debugging memory issues or certain memory issues that you can run into Backbone, and then a whole section on dealing with subviews. So I think at this point I'm going to say, pick one. What do people really want to see? Well, I'll just, what? Do you have?
That was for memory.
Memory? Okay.
Memory's good.
Memory's good. All right, let's look at memory. So with Backbone, you can run into memory issues if you're not careful. So I thought I'd go through an example of where you can run into a memory issue and what to do about it. The first thing I think to probably, and let's go ahead, I actually want to go ahead and start up this example application. Alrighty. So, if you haven't seen the Chrome developer tools already, go look at them today. If you're doing any kind of client-side development at all, they're super, super helpful. And specifically, the thing that we're going to look at is there's actually a memory profiler in the Chrome developer tools that's really helpful when you're troubleshooting memory issues. And so in order to demonstrate this issue, and I was hoping I had this populated with some data, but I don't. That makes me kind of sad. So this may be harder to actually demonstrate than I thought. So, so I have this. This is actually an early version of our scheduler app that we use to actually schedule people on projects at Gaslight. And the way it works is we have a list of all our developers and weeks going across the top and projects going down the left side. And we just sort of drag people on the projects, and then they disappear from the bench down here. And I can drag people on projects. And what we actually want to see is that if you go into the profile section and take a heap snapshot, you can actually see how much memory that you're using. And what I wanted to demonstrate over here is if I, oh, okay, there everybody is. I was like, trying to figure out, that makes sense, because when I gave this talk, it was January, and so all my data was way over. Oh well, sorry about that, guys. So if I go back and forth enough, I should be able to demonstrate the problem by taking another heap snapshot. And seeing that now I'm up to 13.1 megs. It's actually not leaking as bad as I think it should be. I wonder if I'm using the right version of the app. I think rather than trying to worry about that too much, what I really want to do is kind of show you what the tools are and what the problem is. Yeah, it's doing something terrible where it's like hiding the most important column from me. So what's really nice about the Chrome tools is it gives you a list of the things that are actually taking up memory. And if I go down, I can actually start to pick out, if I go down far enough, I can start to pick out things within my app that are actually my domain objects. For example, we have an assignment, and it'll show me like all the assignments that are there. Assignment just represents the assignment of a contractor to a given week. And what I can actually start to look at is, okay, how many of those are there? In this case, assignment of a number of 41 is probably about right. And I think I might be pointing at a version of this code base where I have the problem already fixed. But what would happen is if I move back and forth enough, assignments would just pile up, and pretty soon I'd have like 300 assignments there, and that would be a cue that, hey, you have way more assignments than you probably are displaying on the screen. What the heck is going on? And so the profiler will let you kind of hone in on the problem pretty quickly. And in this case, what's going on yeah, I should, seems to me this should still exhibit the problem, but in any event, what's happening here is I have this project that's responsible for rendering a project going across this ways. And every time that I'm scrolling back and forth by weeks, it's going to need to re-render. So the first thing it does is clear all the assignments views, and it does that by calling remove on the view itself, which will clean up the DOM element and get rid of the view. And so that should essentially, get rid of that assignment view and let the garbage collector collect it. But the problem is, oh yeah, so this is where I've already fixed it. Okay. So the problem was, in an earlier version of this app, it was calling model.bind and listening to an event on that model, which resulted in the model itself keeping a reference to the view even after it had fallen out of scope and should have been garbage collected. And the solution to this problem is actually to use a newer feature of Backbone called Listen To. Listen To does the same thing except from the other side. Instead of saying, I want to bind to a model's event, which causes the model to keep a reference to the view, Listen To does it the other way and says, I want to listen to this model, and by doing that, the view has a reference to the model that it's listening to, and when the view gets removed, it will automatically unbind all of those listeners, and that will cause things to be cleaned up properly. So the moral of the story is you kind of have to be careful with when you're listening to events, establishing references that need to be cleaned up later. And Listen To is a really good way to deal with that problem. But at this point, we've kind of gone over a little bit, and I'm running out of battery juice. So if there are specific questions, I'm happy to answer. Otherwise, the stuff that I didn't get to when that InfoQ talk comes in there, I actually did a much better job of time management when I was at CodeNash, so you can see all that stuff there. But thanks.
Yeah.